Hello students. In the last part we saw about the separation of metals which was based on gravitation. Now we are going to do the second type, that is extraction of metals. Now how metals can be extracted. So first, how the extraction of reactive metals can take place. In the previous parts we have learned about the reactivity series, and we know that the reactivity series decreases as it goes down. So for example, potassium, sodium, aluminium, these are the reactive metals. Now these metals, you must be remembering about the cations and anions. So whenever the cations are formed, that means it is formed by losing the electrons. So these reactive metals, they have the capacity to form cations by losing the electrons in their outermost shell. So if we take the example of reactive metals, so they react vigorously with dilute acid and they give out hydrogen gas. Next is the highly reactive metals. So these highly reactive metals, they burn by reacting with the oxygen from the air, and their extraction has to be done by the electrolytic reduction. We have learned about the electrolytic method. We know that there are two things, that is cathode and an anode is there. So for example, if we have to obtain the metal sodium, so that we need to obtain by electrolysis of their molten chloride salt. So for example, the chloride salt is sodium chloride. So if you have to remove sodium from sodium chloride, so you need to obtain it by electrolysis process. So now what happens in this process is that the metal is deposited on the cathode. So there we know we insert two, that is one is cathode and one is anode. So from the cathode, we can remove the metal. So the metal gets deposited at the cathode and the chlorine gas is liberated at the anode. So from sodium chloride, the sodium will be deposited at cathode and the chlorine will be liberated from the anode. So our cathode and the anode reaction becomes like this. The Na plus, that is and we add an electron to it, so Na at the reduction and chlorine, that is at the oxidation, from the cathode and from the anode. Next is the extraction of aluminium. Now aluminium metal is the third abundant element which is present on the earth's crust after oxygen and silicon, and aluminium is reactive metal and it does not occur in the free state. Now aluminium can be extracted from its bauxite. So bauxite में से हम लोग aluminium निकालते हैं and बाकी का जो है वो impurities होता है. Now bauxite contains around 30 to 70% of aluminium oxide, and जो बाकी का part है, that is the impurities which is present. So from there are different methods which we use. So there are two methods that we use to separate aluminium from the impurities. So the first step in the extraction of aluminium is the concentration of bauxite ore. Now bauxite contains impurities like silica, it has ferric oxide, it has titanium oxide in it. So all these impurities should be separated to get the aluminium. Now these impurities can be separated with two processes, that is either by Bayer's method or by Hall's method. We will now see both the methods how they are done. And in both these methods, the concentration of the alumina is obtained by calcination. Now, calcination is the heating of the ore, and it can be done with high temperature so that the unwanted substances can be removed. So the first method is the Bayer's process. Now, in this process, we take our ore, that is our bauxite ore, and we crush that ore. Then that crushed ore is mixed with the solution of caustic soda, that is NaOH, and it is heated at around 140 to 150 degrees Celsius under high pressure so that it gets leached. Then we know that aluminium oxide is amphoteric in nature. Now amphoteric means it can react with both acids and bases. Now as NaOH is a base, so it reacts with the solution of the sodium hydroxide, that is NaOH, and it forms water soluble sodium aluminate. So now we get sodium aluminate from our bauxite. So in this way, the bauxite can be leached with the help of sodium hydroxide solution. Now, along with it, the other impurities are also present, like iron oxide is present, silica is also present in the bauxite. So what happens is that the iron oxide which is present, it does not dissolve in the aqueous solution of sodium hydroxide. So it can be separated by filtration. So when we filter it, so at that time the iron oxide is separated, and the silica, it gets dissolved in the aqueous solution of the sodium hydroxide, and it forms water soluble sodium silicate. So now we have the sodium aluminate, that is which we earlier got. So this sodium aluminate is diluted by putting water into it, and it is then cooled at 50 degrees Celsius, and then it results in the precipitation of aluminium hydroxide. So in this way we get aluminium hydroxide from this process, that is the Bayer's process. Next is the Hall's process. Now in this process again we take the ore, we crush it, and now it is leached with sodium carbonate. Earlier we used sodium hydroxide, but now we are using sodium carbonate. And as it is leached with sodium carbonate, so it forms the water soluble sodium aluminate. And the other impurities which are present in the ore, it can be filtered out, and the filtered which we get, that is then neutralized by passing the carbon dioxide gas, and the result that we get is, that is aluminium hydroxide. So in both the process, that is in Bayer's process and in Hall's process, the end product that we get is nothing but the aluminium hydroxide. Now we need to separate aluminium hydroxide, that is the oxide which is present in it, that need to be separated from the aluminium. So this can be done with different filtration processes, that is washed, it is dried, and also heated at around 1000 degrees Celsius, and at the end we get the aluminium. Next is the electrolytic reduction of alumina. So here we use two things, that is a cathode and an anode. So a tank is made, and the tank inside has a silver lining which is made up of graphite. And this lining which is there inside, that act as a cathode. And there are few graphite rods which acts as an anode, which are dipped in the molten electrolyte, and they work as anodes. So we have a cathode which is the lining outside, and we have few anodes. Now in this method of electrolysis of molten mixture of alumina, so it is done in a steel tank. So we have to make a steel tank here. Now as the melting point is very high, so that is why, to reduce, that is to lower the melting point, so we add cryolite and we add fluorspar, so that the melting point can be lowered, and it can be lowered up to 1000 degrees Celsius. Now as we start the electric current, so as soon as the electric current will be started, what will happen? The cathode and the anode stuff will get deposited at the cathode, and something should be liberated from the anode. So the aluminium which is there, it is deposited on the cathode when you pass the electric current, and as the aluminium, that is the molten aluminium, is heavier than the electrolyte, so it is collected on the bottom. So from the bottom you can get the molten aluminium. The aluminium which will be there, it will be deposited at the cathode, and the oxygen gas which is there, it will be liberated from the anode. So here in this we can see the reaction, that the anode, the oxygen gas is liberated, which is oxidation, and at the cathode we can see the aluminium which is obtained by reduction. Next is the extraction of moderately reactive metals, so which is present in between the reactivity series, that is lead, copper. These are the moderately reactive metals, and they occur with their carbonates. So these metals have carbonates with them. Now it's very difficult to obtain metals from their carbonates, so that is why first, in the first step, that if we have to separate the metal, so first we need to convert it into oxide. So first we will convert the metal carbonate into oxide, and then we will separate the metal from it. So there are two processes that is used. First is the roasting, and second is calcination. So in roasting, the sulfides ore are heated with the air and they form into oxides. And in calcination, the carbonate ores are heated with less supply of air and they transform into oxide. So both this process is the transformation of the carbonate ores into the oxide or the sulfide ores into oxide. So there are two processes, roasting and calcination, if you have to convert the sulfides or the carbonate to oxides. So now roasting is done to convert sulfide. So here we have the zinc sulfide. So zinc sulfide with the help of roasting process can be converted to zinc oxide. So we got zinc oxide with the process of roasting. Next is the calcination. So now in calcination we convert the carbonate. So here we have zinc carbonate, any carbonate can be there. So now we have the metal zinc along with carbonate. So zinc carbonate can be converted to zinc oxide with the process calcination. Next, we have to separate now zinc from the zinc oxide. So that can be separated by using any type of reductant. So here we have added carbon as the reductant. So now zinc oxide, which is there, when you add carbon as the reductant, so zinc gets separated and the carbon and oxygen it combines to form carbon monoxide. So in this way we got our metal, that is zinc. Now it is not necessary that always carbon should only be used to remove the metal or the reducing agent as carbon should be used. We can use other things also, like we can use sodium, we can use calcium, we can use aluminium. So here we have manganese oxide. So here if you have to convert these manganese oxide to the you have to remove the manganese from it. So what we do is we add the aluminium to it. So now when you add the aluminium to it, the oxide which is there, it gets separated and it gets added to this aluminium. So now we have the Mn, that is manganese, is separated. Then we have the powder, that is aluminium oxide, and we get some amount of heat. So it is not necessary that you always use carbon only as the reducing agent. You can use other metals also. You can use sodium, calcium or aluminium. Next is the extraction of less reactive metals. So these reactive metals are present at the bottom of the reactive series, we know that, and these are usually present in their free state in nature like gold, silver, platinum. Only copper is present with few impurities. So copper is mainly found with copper sulfide. So you can obtain copper, and when you heat the copper sulfide, so we can obtain copper from it. So this can be obtained. Here in the reaction you can see that copper sulfide is heated in presence of oxygen, so we get copper oxide first, and then copper oxide is then again added with copper sulfide, so we get SO2 gas and we get copper. Next step is the refining of metals. So now whatever step you use to separate the metal, but there are still some amount of impurities that are left in that metal. It is not the pure metal. So if you have to obtain the pure metal, so we need to remove all the impurities from it. So electrolysis method can be used in refining of the metals to obtain the pure metal. Next is the corrosion of metals. Now you must have seen that many metals change their color after some time when kept in the open air. So this is the corrosion of metal, and usually it is the destruction of material, and slowly that material is of no use. So corrosion is a natural process that converts the metal into a chemical stable form such as oxide, hydroxides or sulfide. And we know that rusting of all any type of material, especially the iron articles, it causes financial loss. Thus corrosion of iron, especially rusting, is a big problem. Now, if we talk about the iron metal, so iron reacts with the moist air and you can see a deposit of reddish substances formed on it, and this substance we call it as rust. The carbon dioxide in the moist air, it reacts with the copper vessels and they develop a greenish layer on it, and this is called as the platination of copper. Then on exposure of air, the silver articles turn blackish. You must have seen if you wear those pile or the anklets, then you must have seen it turns into black color. So it is because of the layer of silver sulfide which is formed by the reaction of silver with the hydrogen sulfide which is present in the air. The oxidation of aluminium is also done. So a thin layer of aluminium oxide forms on the aluminium articles. So in this way, any type of metal which is there, it can be corroded. It can be either iron, it can be copper, silver or aluminium. Now, how can be the corrosion of metals prevented? So it can be prevented by coating the metal with something which do not react with the moisture and the oxygen. And to fix this, a layer of any substance on the metal surface that the contact of the metal with the moisture can be avoided. Metals can also be coated with paints, oil, grease or varnish, and also there are other methods of preventing the corrosion which is done by coating a corrosive metal with a non-corrosive metal. So it is done by few methods. So let us look at few methods. So the first method in prevention of corrosion is by galvanization. So in this method, we apply a thin layer of zinc on the corrosive metals like iron or steel. And these zinc layer, it prevents this method from eroding, and it also gives a shiny color to all these metals. Now the basic principle of this method is that if you apply zinc layer first, so the zinc actually is more electropositive than iron. So first the corrosion will be there on zinc. So first the zinc will be corroded and it will be washed away in the rainy season, and after few years then the iron will be exposed and then the rusting of iron starts. So in that time you can again coat the layer of zinc on it, then again the zinc will start to erode. So this is called as galvanization, that is using some other substance to prevent our main substance. Next process is tinning. Now in this method we use the molten layer of tin. The name is tinning, so we use tin and it is coated over another metal. Like we can coat it over copper or brass, and this process is called as tinning as we are using tin as our prior substance. Next is anodizing. So it is done to prevent corrosion of aluminium. So aluminium here is coated with a strong film of its oxide, and this is done electrically. So for example, when aluminium is anodized, so a thin layer of aluminium oxide is formed and it obstructs the contact of aluminium with the oxygen and water, and thus it prevents the oxidation, and indirectly it protects the aluminium from getting rusted. And this protection can be increased if we want by making an oxide layer of thicker oxide layer, and this can form by the process of anodization. So as much thick you want, you can prepare that layer so that you can prevent it from corrosion. Next is electroplating. So this is very simple. Now in this we use a less reactive metal. So a less reactive metal is coated on a more reactive metal by the process that is called as electrolysis. For example, silver is plated on the spoon. So we get silver plated spoon, we get silver plated different plates we get. Even jewelries are gold plated. So these prevent the corrosion of that particular element. Next is alloying. So in this we prepare an alloy. So to prepare an alloy you need a homogeneous mixture which is formed by mixing a metal with other metals or non-metals, and there is a fixed proportion, like for example one is 10% so other is 90%. So this fixed proportion is there and this forms an alloy. Now nowadays usually whatever metallic substances that we use, they are formed from its alloy only, And the main reason of making an alloy is that it reduces the chances of getting corroded, so the corrosion of metals can be prevented. A few examples of alloy. So bronze is an alloy which is formed by 90% of copper and there is 10% of tin. And you must have seen that bronze statues which are usually made, they do not get affected by sun and rain. Then another alloy is stainless steel. It also do not get affected by air and water and it does not get rust. If you have steel in your home, you must have seen the steel does not rust. It is because it is an alloy which is made up of 74% of iron. It has 18% of chromium in it and it has 8% of carbon. So nowadays, usually many things are made from alloy only. The coins that we use, all of these are made up of alloys.